from the current slide. Okay, and I think we finished example 3 last time. And we're starting to do area of an oblique triangle. But before we get started, any questions on anything we've done so far? And sadly enough, there's this week and next week and finals week. Okay, so we need to move along what we can in chapter 6, and wherever we end at the end of next Tuesday, then that's as far as we'll have. And what we'll do for your last test, I'll give your take-home test next Thursday, okay, and then I'll also give you your final exam next Thursday. They'll both be short, much shorter than the first 3 tests have been, much shorter, 1 page each, and I'm sure you can get them done in a week. Yes?
You said we finished doing like our study next Tuesday, but if you're giving us it Thursday and it's take home, can we just finish it Thursday?
What's that again now?
Like, when did you say that we're going to be doing this again? You said next
We're going
Tuesday.
to do it today and next week, Tuesday and Thursday of next week.
Okay.
And then at the end of Thursday, I'll give you your take-home test for chapter 6 and your final exam. Take-home also. Okay, and they'll both be much shorter than the first 2. Basically 10 questions each. That's it. Okay. And the comprehensive final is stuff you've already done pretty much. And this test, again, because it's not going to be a whole chapter, it's going to be pretty easy too. And these are pretty fun things. Law of sines so far. And this area of oblique triangle, I think you'll find is sort of fun too. Now, it doesn't use the law of sines, but it looks a lot like it. So here's what we've got. The same procedure that we use to prove the law of sines, remember using the height of the triangle, that leads to a simple formula for the area of an oblique triangle. Now remember, oblique triangle just means one that is not a right triangle. It can be all acute angles or one obtuse and 2 acute angles, whichever. So here's how we find the area. Now, before this, somewhere back in your past, you probably took areas of triangles. And you had that simple little formula. It's the base times the height. 1/2 the base times the height. Okay? That was the area of a triangle. Now, one thing that's a little problematic with that. Usually it's no problem to find the length of a base. No problem there at all. But how do you know what the height is? Because this needs to be a perpendicular line. How do you know where is perpendicular here? It's a little sketchy, okay? You don't know exactly how to find that, okay? Well, now that we know trigonometry, just like we did for law of sines, the sine of angle A is opposite over hypotenuse, h over b. So now we know that h is equal to b times the sine of A, right? If sine of A is h over b, multiply both sides by b, and you get h is equal to b sine theta. Hey, now we know what h is. Because b, we can measure that, okay? Here's the base, and the height is going to be b times the sine of theta, so put that in there, and we'll show it on the next slide. That also works for an obtuse triangle. The sine of this angle is the same as the sine of that angle, right? Because this is the reference angle for this angle in this quadrant, okay? And sine is positive in both first and second quadrants, so it works either way. And the h over here is the h times b times the height here is b times the sine of a. Okay, so with that in mind, and we know that the area is 1/2 base times the height. That's 1/2 the base. That would be what we call side C times the height, which is b sine A. You don't have to guess what the height is. You know what it is. Okay. You can measure C, you can measure B, both of those pretty easily. If this were, say, a triangular piece of land, finding out what A was, the angle A, that's a little harder to do. And we'll take care of that in the next section. Okay? We'll find another way to find the area. But here you have it. Area is equal to 1/2 BC times sine A. Or you could have used any of the other angles and then had area would be 1/2 AB sine C or 1/2 AC sine B. Notice you use all three letters, two of them lowercase, one of them uppercase. In other words, two are lengths and one is the angle that's in between those two lengths. So there is a simple way to find an area of an oblique triangle without having to know the H. You use trig to find the H. Okay, so the area of an oblique triangle, any triangle is 1/2 the product of the lengths of two sides times the sine of the angle between those two sides, the included angle. That is, area is 1/2 BC sine A, area is 1/2 AB sine C, or area is 1/2 AC sine B. Whichever two you happen to know with the angle in between. Note that when the angle A is 90 degrees, what's sine of 90? 1. That would be 1/2 the base times, see, 90 degrees, that is the height. So you have the same formula again, because the sine of 90 is 1. So that's 1/2 the base times the height. Because it's 90 degrees, this is the height, that's the base. Similar results are obtained for if angles B or C are 90. It's just back to the base, 1/2 the base times the height. But if they're not 90, still works. Okay? So, here's example 6. I think it's the same in the book. Find the area of the triangular lot with two sides of length 90 meters and 52 meters and an included angle of 102 degrees shown in the figure. I don't think they're showing us the figure. Yes, they are. Look at that. Good for them. Thank you very much. I didn't have to draw it. Okay? So, they said A is equal to 90 meters. B is 52 meters. It looks like it's about right. And the angle C is 102 degrees. How do you find the area of that triangle? You tell me. Ooh. What is that area? Whoa, let me get my pen. Uh-oh, it started doing this mess again. Okay. The area of this triangle. Okay, area of the triangle is what? 1/2 A times B times the sine of C. That's it. That's 1/2 of 90 meters times 52 meters times the sine of 102 degrees. Okay? That will be, I'm going to see if I can get this to erase. There, it did. Don't know if this is helpful. I'm just going to take half of 90 and make it 45. No, I'm going to take half of 52 and make it 26. Leave the 90 where it was, because that's easy to multiply. Okay. But we still got to use a calculator to get sine of 102, but that's not bad. Be sure you're in degree mode, of course. So 90 times 26 times sine of 102.
2,280.
Okay, wait, a little. Okay, 2,200 and what?
88.
Okay.
88.
88.
0.86.
Let's call it 89 then. And that will be meters times meters is meters squared. Now, in reality, we really don't have that many digits. If you're doing this properly, you would have said about 2,300 square meters, because you really don't have enough precision in anything they gave you to give you 4 digits here. You really should stop at 2, so you should round this at 2,300. But I bet you the book even takes it further than that, don't they, or do they? Nope, they round to 2289, which is more than they're allowed. Okay, but they do it anyway. And by the way, there is a check quit there. Please do that. But before we move on, let's just make sure they did it the same way we did. Goodness gracious. Eyes are stinging. Okay, the area of the triangle is 1/2 AB sine C, just like you said. And that's 1/2 of 90 times 52 times sine of 102. They left off the units, but they're math people. They, I guess, can be forgiven. Oh, but they put them in here. 2,289 square meters, approximately. And I argue you don't have that many digits, but this one I won't cry too much. Okay, so that was example 6. Now let's go to an application problem, as if some of these weren't. Okay. Here's a course for a boat race. What a joy. Starts at point A, up there at the top. Okay. Proceeds in a direction, remember how we did directions? South 52 degrees to the west. And that shows us exactly that. You're starting at A and you're heading off in the direction of south 52 degrees toward the west. So that would be very nicely put there. Okay? Then, in the direction south 40 degrees east. So you stop here at B, they don't take to point B, okay? And then when you reach point B, you do south 40 degrees east. Well, there's that. Oh my, we have a problem. That's not even inside our triangle, is it? So is that at all helpful to us? And then you go back, you go to point C, and then finally go back to A, which is, with point C lying exactly 8 kilometers directly south of point A. The question is, approximate the total distance of the race course. If you can call it that. It's all over water. Okay. So, what you want to know is C plus B, A plus B. But we know B. That is 8 kilometers. The side opposite B is, opposite angle B is 8 kilometers. Okay? We know one side. We know one angle. We're given another angle, but it's not inside the triangle. So where do we go from here? Don't know if you had geometry, possibly trig before, but more like geometry. What about it now?
Is it the same as the...
Very good. Angle C is exactly the same as B, and here's why. These two are parallel lines, because this is due south here, that's due south there. So these are parallel lines cut by what they call a transect, or something like that. Okay, and if you have two parallel lines cut by another line, then the interior angles are equal. The opposite interior angles are equal. Okay. And sure enough, angle C is the same as B, 40. So we can put that in the picture. Okay, so this is also 40 degrees. Okay. Now, we have two angles and the side in between those. We don't have a matched pair here. How are we going to solve this? Huh? Second?
We can either find, like, subtract that from 180.
Absolutely. Anytime you have two angles of a triangle, you can figure out the third one. So that's going to be our next step. What is that third angle? And like you said, add these two together. That gives you 92 degrees. And subtract that from 180 degrees. And that will give you, is it 78 degrees? No, 88 degrees. 88 degrees. So that angle there is 88 degrees. Yeah, it looks pretty close to 90, not quite. So now you know the third angle, which is 88 degrees. All right. Good. All right. Now what can you do? You got all three angles. We're not interested in angles. We want to know what the sides are. We only have one side. How are we going to find the other three? Two. Second, law of sines. How does that go? Second, 8 over the sine of 88. They really like their 8s here, don't they? Is equal to little a, which we don't know. That would be this side here, over the sine of 52 degrees. There it is. Now, how I like to do it, the book does it slightly differently, but how I like to do it is pick the one you know that you don't know, and do that cross product. A times the sine of 88 degrees is equal to the product you do know, 8 times the sine of 52 degrees, and then divide both sides by the sine of 88 degrees. There's different ways you can do this. This is just how I see it for myself. There are other ways to do it. The book has another technique which is perfectly fine. May actually be a little better. You might understand it better. Go for it. And then all you do is do the calculation. 8 times the sine of 52 divided by the sine of 88. Be sure you're in degree mode. Okay? So A would then be approximately equal to
6.
one more time.
6.
6? Yeah, okay, yeah, I got it. 6 kilometers, okay. All right. All right, 6 kilometers. Does that make sense? Angle A is 52 degrees, so side A should be less than side B because angle B was 88 degrees. And sure enough, 6 is less than 8. So at least qualitatively, this makes sense. So this is going to be about 6 kilometers. Okay? And what now? What's that? Yeah, we have to use law of sines again. And use the one you know, the one they gave you. 8 is the sine of 88 degrees. As C, that's the one we're looking for now, is to the sine of 40 degrees. Now, you don't have to write that down again if you just wanted to plug it into your final thing. But just to remind yourself, this will be sine, cross product here, C times the sine of 88 degrees is equal to 8 times the sine of 40 degrees. Okay? Then divide both sides by the sine of 88 degrees. Okay, these go out, and you have little c equal to what? About 5? Okay, approximately 5 kilometers. Okay? Now, does that make sense? This winds up being our smallest angle. That better be the shortest side. Sure enough, at least qualitatively, that matches. So that's about 5 kilometers. Okay? And then the answer to the question, approximate the total distance of the race course. 5 plus 6 is 11, plus 8 is about 19 kilometers. So the answer is approximately 19 kilometers. Now, I bet you in the book they're going to do a lot more decimal places than this, and they're still going to get about 19 kilometers, okay? 19.46. So let me go on. Is it okay? I'm going to erase this, all right? And we'll see how they did it. Oh, I didn't need to erase it. I just did this. Because the lines BD and AC are parallel, it follows that the angle BCA, that's the angle over here, is equal to the angle CBD. Okay? If you look at the things, you see those angles make sense. But without a picture in front of you, blah, blah, blah. Okay? So, consequently, the triangle ABC has a measure shown. 40 degrees at angle C, 52 at angle A, side B is 8. Can't use the law of sines yet because you don't know any matched pair. But, of course, you do know, or can calculate pretty easily, angle B, so that's the next thing to do, 88 degrees. Good for them. They did the same thing we did. And using the law of sines, I don't like them putting it this way, but I guess it's perfectly fine. I always list the one I know first. B over sine B is equal to, and then go from there, A over sine 2, which is the same as C over sine 40. So A would then be, they go on and solve for this at the first thing, the B equal A. Doing the same thing we did, except it's less obvious what they do in my book. Maybe to you it's perfectly obvious. But this is the ratio we know, and since this was on top here, we just multiply both sides with that. And yeah, it's pretty obvious. And same calculation you did, and they got 6.31 kilometers, okay? And then they did the same thing for C. The ratio we knew times the sine of C, sine of 40, and that gave us 5.15. Now this is one time that both of our rounds were down, but guess what? They still add to, when you add all those three together. So you see, this to me is sort of irritating. You have this to one significant digit, and you're adding two things that you calculated to three significant digits. How can you possibly be that precise? You can't be. So that gave you 19.46 kilometers, not knowing what the decimals were here, but they act as if they do. But guess what? We said approximately 19. That is approximately 19 kilometers. Sure, it may be a little bit more, but it's not approximately. So 19 is as good an answer as 19.46, and I think better substantiated. All right, there is a checkpoint. Well worth your effort to do the checkpoint. Okay? Let's fill in the blanks for the vocabulary. And blank triangle is a triangle that has no right angle. Say again? Oblique, you're right. Okay? For triangle ABC, the law of sines is side little a over sine capital A, degrees, angle A, is equal to blank, which is the same as C over sine capital C. What goes in the blank? A over sine A is equal to blank, which is the same as C over sine C. B over sine B. Perfect. Now, number 3, 2 blanks and 1 blank determine a unique triangle. Okay. For law of sines, 2 angles and 1 side always will do it for you. Because if you know 2 angles, you got the other side. Okay? So 2 angles and 1 side always will determine a unique triangle. Now, number 4. The area of an oblique triangle ABC is either 1/2 BC sine A or 1/2 AB sine C, or Got it. 1/2 AC sine B. Perfect. Homework exercises here. I think I assigned most of these before. Do either 5 or 7. Those are the two with pictures. And then either any of the odds 9 through 21. All those are at calcchat.com. 11 is at calcview.com. Then do any of the odds 23 to 31. They're all at calcchat. Goodness, my eyes hurt. 29's at calcview. Then do either 33 or 35 or both. They're both at calcchat. 33's at calcview. Do any of the odds 37 to 43. They're all at calcchat. 37's at calcview. And then of the applied problems, do any of the odds 45 through 53. They're all at calcchat. None of those at calcview. Okay? Goodness gracious. 55 and 57 are both true-false questions, so take a look at those, see if you can figure out why they're true or why they're false. What would have made them true if you had written it correctly. 59 is one of those error analysis, which I really don't care for because they're showing you something that's wrong, but you have to figure out what's wrong with it. Okay? And then 61 is a think about it problem, so you can read that and think about it. Okay. I'm having trouble breathing. I think what it is, because it was L Day, I wore a t-shirt, short sleeves, and then it turned cool today, and so it seems to have clogged me up. Sorry about that. Okay. Less in 2. Any questions on 6.1? All right, let's move on to 6.2. Well, there it comes. Okay, now, while we're waiting for this to come up, let me make a few reminders. Here, my very best class, I've received 0 research papers. 0! That's a none, okay? All right. I still have 1 test 1 missing. I've only received 1 test 2, and you all have test 3 already, right? Okay. I don't have any of them. You have them, okay? So please get those in. You only have this weekend is your last weekend for the paper, and really for all those tests too. Procrastination. Okay, so try to get everything caught up. This is, in farming we used to say we're on the short rows now, okay? Huh? I can't hear.
May I be excused?
Sure. I mean, anytime. All right. So they finally came up here. Additional topics in trigonometry. Let's go to current slide. This is chapter 6. Section 6.2 is the law of cosines. Okay? We've done the law of sines, but that only works for certain situations. The law of cosines we're going to use to solve the other situations you could have with an oblique triangle. That is, if you have a triangle, you don't know any angle, you know the 3 sides. You can use the law of cosines. No way to use the law of sines with that because you don't have an angle to pair with. Or, if you have a side, an angle, and a side, you don't have a pair you can do, law of cosines works there too. And those are the 2 cases we'll use law of cosines. We'll also use law of cosines to model and solve some real life type problems. And then there's yet another formula for an area. This is called Heron's formula. Back when I was in school, like high school type thing, they called this Hero's formula because people misspelled this name, okay? I guess in the Greek or whatever, they thought it was Hero, but it really should have been Heron's formula. Okay, to find the area of the triangle. Okay? Now, this will remove the problem of having to measure an angle. You can do this one with 3 sides. And those are easy to measure. If you have a triangle anywhere it is, measure this side, that side, that side. And with those simple measurements, you can get the area. But we'll get that at the end. So, introduction. 2 cases remain from the list of conditions needed to solve an oblique triangle. We could do angle, side, angle, law of sines. Side, angle, angle, law of sines, or angle, angle, side, whichever way you want to say that. Or, what's the other one? Angle, side, side. You could do that, okay? No, side, side, angle, sorry. Side, side, angle, woo-hoo. Side, side, angle. But the 2 that we couldn't do are side, 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 and side, angle, side. No way. You don't have any way to come up with a matched pair of the side and its opposite angle. So, to do these, when you're given 3 sides or 2 sides with the angle in between, none of the ratios of the law of sines would be complete. No way to proceed. In such case, we'll use the law of cosines. A law of cosines can be written in 2 forms, one they call the standard form, the other the alternative form. In each of these forms, you can solve for either one side or one angle. So you actually have 6 possibilities here. But you see, since you get to name the sides and angles, they're really just 2, okay? So in standard form, it is, and frankly, this is the one I would like to use rather than these 2, okay? There is a reason for it. C squared is equal to A squared plus B squared. That sounds pretty familiar, doesn't it? What would that be good for? And what's the condition that it has to be met for a Pythagorean theorem? Has to be a right triangle. So therefore cosine C, if that's a right triangle, that must be a right angle. And what is the cosine of 90 degrees? 0. So sure enough, if C is 90, this is Pythagorean theorem. If C is not 90, then this is the law of cosines. So it's A squared plus B squared minus 2AB, these same 2 letters here, cosine C. So notice here you have 2 sides and the angle in between. Okay? 2 sides, the angle in between, 2 sides, the angle in between. The one that you're looking for on this side of the equal sign, and it's always a square, remember that. Then it's B squared plus C squared minus 2BC. All these letters are the same, but the cosine of the angle corresponding to A. Now the alternative form, this would be the one you would use if you're given 3 sides. Because over here, you just have angle. Given 3 sides, you can calculate the angle. Okay? By an inverse cosine. Okay? So what you do here is, since this is a minus sign, add it to this side and subtract this from that side. So you wind up with 2BC cosine A equal to B squared plus C squared minus A squared. There's your B squared minus C plus C squared minus A squared, and then divide by the 2BC. So again, the angle here that you're looking for, that side, opposite side, shows up 1 time in the numerator, is subtracted. The rest of these are added or divided. That's how I try to help remind myself what that is. Usually I go back to this form and do the math to get that. So whichever one you're looking for, if it's B, use A squared plus C squared minus B squared, divided by 2AC. C, A squared plus B squared minus C squared over 2AB. So those are your 3 forms. And they're fairly reasonable, okay? But you can always look it up if you forget them. I don't ever trust memory. Okay. So here we go. Find the 3 angles of the triangle shown. Okay? And this is starting off with a side, side, side. Okay? Now, they started you with one that is going to illustrate something you always need to keep in mind with law of cosines. Here you have the three sides, and you're looking for the three angles. So it's not going to be the standard form. It's going to be the alternative form. And here's what you need to do with law of cosines. If you're given this situation, always start from the biggest angle. Now, how do you know which is the biggest angle? Opposite the biggest side, of course. So let's start and figure out what the cosine of B is. Now, here's why. Okay? Remember, sine is positive in the first and second quadrant. So an obtuse angle there doesn't give you any problem with sine. With cosines, that if you do have an obtuse angle, that's going to be your biggest angle, obviously, then that's going to come out negative. Okay? If you started with one of the others, you would tend to have what you call an ambiguous case. And you might come up with an angle, trying to solve it for, it tends to mess up. So always go for the big angle first. Okay? And that's what they say down here. It is a good idea to find the angle opposite the longest side first. Okay? In this case, it will be B. So what is our law of cosines, which you're solving for the angle B? It would be, say again, A squared plus C squared minus B squared. That's the only place a B will show up here, divided by 2AC. So let's plug and chug. That will be 64 square feet. I'm going to go on and put the units in since they gave them to us. Plus, boy, 14 squared, that's one beyond which I remember. 196? Okay, 196 square feet. And 19 is certainly beyond what I do. Second? 361. 361 square feet. Okay? Divided by 2 times 8 times, and this will be feet, times 14 feet. All right. Now, I put the units in for a reason. Goodness gracious, I'm having trouble breathing. Let's add the two positives here. That adds to 260, right? Subtract that from 361, that will be 101 square feet. Divided by, oh, and it's a minus. Don't forget that. That's important. That's why we did it. Okay? Let's see. 8 times 14 is 112. Double that, or 224, I think. And that's also square feet, which is a very good thing because the units cancel out. Okay? And that then yields, here you need a calculator. It's going to be a negative number, 0. What? 4508. Okay, and that's what cosine of B is. Okay, now how do you get what B is? Yeah, arc cosine or inverse cosine, either one, whichever your calculator says, and what you get for that. Second.
63.
63.19 degrees.
Oh, I didn't have it as negative.
Did you? Second.
I didn't have it as negative. Okay, 116.
116.8. So let's call it about 117.
I just wrote the negative sign when I divided.
Okay. So that's approximately 117 degrees.
Yes.
Okay. Now that looks reasonable by their picture, but no guarantee they got the picture right. Okay. But what does look, that definitely is more than 90, and it's the fact that your lengths worked out the way they are, you know it's got to be 90, so that's why it's a good idea to start with that one. Okay? And you get about 117 degrees. Well, that gives you one angle. How do you get the other two?
Can we use law of cosine or law of sines?
Yeah, okay. You could use the law of cosines again, but look, you got all this squaring, addition, subtraction, whereas law of sines was just a simple proportion. And since you now know an angle, sure, it's a calculated angle, but you're going to have to use it anyway. Actually, if you did do law of cosines again, you would use only the known quantities. But then, too, you may get into that ambiguous case, so I think it's probably safer to do this. So what would be your next step? 19 over the sine of 117. Now, if you have that whole angle on your calculator screen, go and take the sine of it there. Don't round, okay? And set that equal, and which one you want to do next. It really doesn't matter. A, so that would be the same as A over sine of A. Okay? And that should be a small angle, so let's see what we get. 19 times the sine of A is equal to 8 times the sine of 117. Okay? Divide both sides by 19, and that gives you sine A. 8 times the sine of 117 divided by 19, I guess it is. Goodness gracious. By Thursday afternoon, especially the week after I've had a treatment, I'm so out of energy. It's just, my arms feel like lead. Okay. Oh, I should have given this announcement too. I forgot it. It seems like every Thursday something like this comes up. I will be on Birmingham campus tomorrow. I can almost promise you that. But I won't be there at 7:45. Because this drug that they had me on February, March, and now into April has done such a good job with the white cells. My white cell count's really low right now. I mean, lower than it should be. But it's also, the tiredness comes from knocking out the red blood cells too. They're not as low as those, but they are still low. But it also wiped out the neutrophils, which are the things that are the best disease fighters. Now, they've been like this for 2 months. Actually, the previous drug knocked out the neutrophils too, so I was really low on them, I'd say, for over a year. Okay? But for some reason now, they've gotten really upset. My neutrophils aren't coming back as fast as they wanted them to. Actually, they are coming back in between doses, but then they give me another one. So it's sort of sawtoothing, you know. But I'm not too worried about them. But suddenly they've gotten very worried about them, and they wanted to give me a shot to boost the neutrophils. But they waited too late, and you have to do it within a few days of the treatment. And since I had the treatment on Friday, it's already past that. So they're giving me a substitute one that's a much, it sounds awfully expensive, and it's also awfully technical of how you do it. has to be done by shots. Well, it should be done 4 days in a row. And so that means I would administer myself. Well, I've got one of the nurses here to say she'll give it to me, so because I've never given myself a shot. I don't know if I do it right or not. Okay, I don't even want to try. So I asked my wife if she wanted to. She said, "No way," because she has given shots before, but that was back when she was in college. So she said, "No." Okay, so they had me come in Wednesday morning. They had left a message on the machine Monday for me to come in Tuesday. Well, I couldn't come in Tuesday. They didn't open until 8, and I had a class here at 8. And then I didn't leave here until 5:45 or 6 o'clock, and they were already closed by then. So I couldn't really do it on Monday, but on Tuesday. So I called them Tuesday and said, I really can't come by on Tuesday. I can Wednesday morning because my first class is 9:30 on Wednesday morning. He said, "Oh, okay, we'll come by then." Okay. So I went by Wednesday morning, and there was a message when I got home, come blah, blah, blah. But I went by Wednesday morning, but they had found out more information after that. Okay? And that information was, it's a specialty drug that you have to, it was just all sorts of a mess. They didn't seem to know that beforehand. So I went by and they didn't have it ready for me, and it was hard to get it, and they were going to try to get it, but I needed several days in a row, and I couldn't come Thursday, called today. So anyway, I sat there and graded papers for about an hour or so until it came. I said, I have to leave at 8:45 to make my 9:30 class. But 8:45, the nurse came up to tell me, "No, we can't do it yet." I was already packing my bag, and then she had to tell me. So, when she first had me go down to the pharmacy to see if it was ready, they hadn't received the order. That's when they found out they had sent it to the specialist pharmacy, and then they found out then they couldn't even get it to them, that they would have to order it through a pharmacy in Memphis. And so it would have to come to my home, and I would have to administer it myself. Well, so I'd wasted all morning without getting a shot. So I came back to work, and then in my office hours, I had to call around, call Memphis, call this. I actually wound up for Orlando or somewhere, not Memphis. They have offices in 2 places, so the number they gave me took me to Orlando. And they said, well, we can mail it to you, but of course it's medicine, so it comes shipped cold. You have to sign for it and receive it. You can't leave it on your doorstep, So that was going to be a problem because both my wife and I worked. So anyway, but they had just gotten the order themselves, and it was going to take them a few days to process it. So anyway, we hope to have some word from them tomorrow afternoon or evening or sometime to let us know what to expect for shipping the drug. Well, I happened to tell the nurse that I wouldn't be in town this weekend. Well, where are you going? Well, I'm going over to the farm. The farm? Yeah, we're loading up a load of cows. Cows, they have disease. So you need to come in Friday morning and get a shot. Okay. So now I've got to go in tomorrow morning. Even though I thought all this was taken care of, I've still got to go in tomorrow morning and get the shot they couldn't give me on Wednesday. Okay, so anyway, I will be waiting for the shot at 7:30. They don't get there until 7:30. So I'll be waiting for the shot at 7:30. Hopefully it won't take very long, and then I can get on to campus, but I won't be there before probably 8:15. That would be the earliest I could get to campus. And if they delay or something else, then I'll be later than that. But I will be there sometime in the morning, and I'll be there at least until 11:45. But the trouble is, I've got to leave shortly after 11:45 because I've got to head over to Georgia to lay cows. Okay, so.
You would think thought they looked into all of that before.
What's that again?
You would have thought they would look into it before.
Yeah.
Have you go through all
That's the issue. But they were sort of inventing it as they went. Since the real problem is they missed the window on the Neulasta.
Yeah.
And the previous doctor I had, once my neutrophils went low, he gave me a Neulasta. I mean, he just had one given to me on the spot. This time, they delayed, and then finally found out, oh, he needs one, but it's too late to give it to him. So then they had to go to this other one that they're not familiar with. It must be a new drug because it's so expensive. But the good news, hopefully, we hope this is true, I've reached my copay for my drugs this year already because this drug I've been getting is really expensive too. So I've already exceeded my copay. So it should all be covered. I sure hope so. But it's costing the insurance company more because they missed the Neulasta thing. Sorry, that was way too much time. Okay. So there was example 1. Les, that's how we did it. Oh, wait, no, we didn't finish, did we? Did we find out what A was?
I ended up getting 22.
22 degrees? Okay, let's see if that sounds like it makes sense. 22 degrees. Well, I'll tell you this. It has to be less than 117 because not 8 is a lot less than 19. Now, you can't go by ratios, but it is a lot less. So that is at least making sense. So we got 2 angles, 117 for B. How do we get C? Oh, we don't need law of cosines. We don't need law of sines. We can just subtract. And sure enough, that'll give it to us. Add those two together and you get 139. Subtract that from 180. And you get 41 degrees, we think. Okay? Now, does that make sense? Well, the side over here is greater than 8, so you hope this is greater than that. It is, but it's less than 19, so it should be less than 117. It is. Qualitatively, you're in the right ballpark. Let's see how we did quantitatively. Okay. Let's erase all this ink if you're okay with that. And let's see what they did. Good idea first to find the angle opposite the longest side. Side B in this case. Using an alternative form for law of cosines, you see cosine of B is a squared plus c squared minus b squared over 2ac, exactly like you did. And that was 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14, which is just like you found negative 0.45089. They took it maybe one more digit. And then they did an inverse cosine of that, or arc cosine of that. But you know now B has to be an obtuse angle. Okay? And they came up with about 116.80, which we, I think, wisely said about 117. At that point, it's simpler to use the law of sines than go back and do law of cosines again, even though you're using an angle that's a calculated angle. So if you use all the digits you had there and set this up that way, then you find the sine of the angle is that. Do the inverse sine. You know you won't have another obtuse angle. You can't have it and be less than 90 degrees, okay? 180 degrees. To be 180 degrees. So it must be acute, so that gives you A to be about 22 degrees. The 0.08 is extraneous. Then you subtract those two from C, and you get B, which is about 41 degrees, which is, I think, exactly what we got. So you see, we came really close without having to have all those decimal points, which you are unjustified. Okay. Now it says, do you see why it was wise to find the largest angle first in example 1? Knowing the cosine of an angle, you can determine whether the angle is acute or obtuse. A sine you can't necessarily, because it's going to be the same. A cosine, if it's a positive, it's going to be acute. Negative, it's going to be obtuse. So that told you you were going to be obtuse. So as an example 1, once you found that angle B was obtuse, you knew that the angles A and C had to both be acute. So then there wasn't, well, which sign do we use? Is this angle or this angle? No. It had to be the acute angles. Furthermore, if it's the largest angle and it's acute, the other two have to be acute because they're less than it. So always go for the biggie first with law of cosines if you're looking for the angles. All right. That was example 1. And they're skipping example 2. So let's us do example 2. Okay. And you can see LarsonPrecalculus.com for an interactive version of this type of an example. It says, find the remaining angles and side of the triangle shown here. Now, I'm going to do my best to draw it. It's not going to be very good, though. We'll start at angle A and do as close as I can to a horizontal line that goes out here to angle B, or point B. Here we have C up here, and we'll connect the sides here. Okay? Now, they give us angle A of 25 degrees. They give us side B of 9 meters. They give us side C of 12 meters. Okay? Now, it looks like my picture is reasonably close. Okay? But what we don't know is side A or angle B or C. Okay? Now, if you don't know any of the 3 angles, go for the one largest side. That was the alternate thing, side, side, side. This is side, angle, side. You don't have any choice here. You've got to go for little a. That's the only possibility you have. Law of sines, you can never get there. Law of cosines, you do. How do you find little a? Remember the law of cosines, just about everything squared. So a squared is equal to b squared plus c squared minus 2bc cosine of that angle A, the one that we know. So it's just a plug and chug here. 9 squared is 81 squared meters plus 144 square meters. Square meters, not cubic. Still looks like a cube. Yeah. Okay, that looks like a square now. Okay, minus 9 times 12 is 108. Double that, you get 216 times the cosine of 25 degrees. Okay. Now, I think you're going to have to use a calculator. I can't read my writing there. 12 squared is 114, and it looks like I wrote 144. Okay? I don't know why it came out that way. You're right, 144. That's what it was. Duh. 144. That's exactly what it is. Okay. 144 square meters. So 81 plus 144 minus 216 times the cosine of 25. What do you get? A little louder. 29.23. Leave all those digits there. You don't really, because you guess what? We're not really interested in what a squared is. That's what you got is a squared. Take the square root of that whole thing that you got there, and what do you get then? A is approximately 5.4. Let's just call it 5 meters. Okay? Now, we'll probably regret that round more than others, but that's all we really can afford because you only have 9 there. So I don't think you can do more than 5 here. You have one digit there. All right, so we think we got this about 5 meters, but keep all those on your screen. Okay, and what do we do next? Oh, law of sines. And does it matter which one? say, yeah, we know the A, so we'll do 5 over the sine of 25 degrees is equal to, now, in this case, I think I would go for this one, because that one might actually be more than 90. It could be. It looks like it has great potential for that. But if you go for this one, you know exactly what it's got to be, and then you'll know what C. So rather than having an ambiguous case there with C, go for B. So this time we go for the little one, okay? Just because we are late, or no, I don't know what. That would be 9 over the sine of B. And what does that produce? We're looking for this one, so the product we know is 5 times, that we don't know is 5 times the sine of B is equal to 9 times the sine of 25 degrees divided by, and then we'll divide that by 5. Okay? So you got your, well, anyway. What does sine B become? 0.7607 or something like that. Then whatever you have on the screen, take an inverse sine of it, and you get B is equal to
49.5.
Let's call it 50. Okay. Again, yeah. Now, when you did the sine of the 20, I'm sorry. When you did the 5 down here, did you use all those digits or just 5?
Just 5.
Okay. So we might have some round off error, but we can live with it. Okay? So if that's 50, that's 25, what would C have to be? 105. Is that what you got? Let's see. By their picture, see, mine wasn't quite as great as theirs. Theirs, I will buy that. Okay? Wait. We may have had a little bit of an issue here. Looks like something isn't turning out quite right. A was, yeah, they used 5.4, and then their sine of B was 0.7034. We had 7607, and that's probably because we rounded. So they got 45 degrees. We got 50. So, yeah, we got off a little bit there, but it's not really all that bad. So their angle C was 110. We got 105. So, yeah, not too bad. But they showed that you have an ambiguous case there. You can avoid that ambiguity if you go with the small angle B. They didn't say that. Side C is the longest side, which means angle C is the largest angle. So C has to be the one at 110. We got 105. And B, the 45, we got 50. Okay. So there is some little problem with the round off, but if you can, once you get it here, to give the answer, you round. But with a few further calculation, if you could have hung on to all those things, then you would have come out slightly different. And it is a pretty good idea to do that. Your answers you round, but the inner workings, keep as many digits as you can. Okay. Oops. I'm afraid we ran out of time, didn't we? Okay. Now, somewhere here, I had a pencil. There it is. Okay, we'll start with applications next time. I had hoped we would finish this. Well, no, we had to finish 6.1. Okay. We almost finished the chapter. Homework exercises, you can do any of the odds 5 through 11. Those have the pictures. They're all at Calc Chat. 9's at Calc View. And then the rest of those don't have pictures. You have to either do them yourself or do them without pictures, and that would be any of the odds 13 through 23. Then do any of the odds 25 to 29. 25's at Calc View. All of them are at Calc Chat. do any of the I's 31 to 35. They're all at Calc Chat. 33 is at Calc View. And stop there. Okay? And we'll pick up with the applications and Heron's formulas later. Okay. So, that leaves us next week. We'll certainly finish 6.2, and we'll get started in 6.3. 6.3 is a new topic, vectors, and it's a fairly long section, so we'll probably still be doing that on Thursday of next week. And then 6.4 is vectors and dot products, so it'll just continue what we're doing there. I doubt if we'll quite finish 6.4. We might. I doubt it. I don't think we'll get to 6.5. So the complex plane, we'll leave that off. That's, to me, the least interesting application of trigonometry. It's there, but it's sort of a stretch. This is all stuff you will use, hopefully. All right, good deal. Okay, we have a good weekend.